Okay, hi everyone. My name's Rohan, and I'm coming to you guys from the United States, New Jersey. And today, here with me is Pepe, who is our Clojure language lead for SLing. I'll let him introduce himself.
Yeah, hi everyone. I'm Pepe. I'm from Spain and I'm very glad to be here with you.
We're going to go and dive into the basics of Clojure today. You can think of this as a sort of chapter zero. And we're just going to go over all of the super core things you need to know before you get started with Clojure. So two things. First, we're going to be using this really great online textbook for Clojure called Clojure for the Brave and True. And we'll put a link to that in the video description. And also, there are lots of environments and lots of ways to set up a development environment for Clojure. Today, we're just going to be using the Replit environment because it's really easy to get started in. There's no hassle, and it's great for beginners. We've also provided a lot more resources in our written curriculum on how you can set up other development environments. So if you're interested in that, make sure to check those out. Okay, let's start with a very basic thing, which is what types of data can we talk about in Clojure? And this is actually really similar to a lot of other languages. So we can have numbers, integers, 1, 2, 3, etc. We can deal with numbers in that way. We can also deal with strings. So this is just text. And that's also a very traditional thing to deal with in programming languages. And we call that a string in Clojure. We also have this idea of what you would probably call a list in another language, but in Clojure, we call them vectors. So you represent it like a list with square brackets, and each element is separated by a space, not a comma, which is probably kind of weird if you come from a language like Python, but actually I think it looks pretty elegant. So a vector of words, that's a vector. And these are sort of the main data types we deal with. We also have an idea of lists, and we'll get to that a little bit later, but there are some important distinctions between vectors and lists. And a final sort of important data type to know would be Boolean data types. So we have true and false values in Clojure. And this is just, the standard is to keep them lowercase because otherwise we don't evaluate them to their true or false value. So I'll just put this all in a comment, but these are the sort of data types we'll be dealing with in Clojure, and it's pretty similar to other languages like Python. But now I'll let Pepe talk to you about the really unique part of Clojure, which is how do we do operations in Clojure?
Yeah, so first of all, you might know that in Clojure, when we are writing a function, we need to use both parentheses. So simple operations are written as the symbol of the operation is the first part of the function, and then all the arguments. So for example, if we want to sum a few numbers, these numbers might be separated by an space. We can also multiply different numbers. First, we have our sign, and later our numbers, and which can be decimal numbers also. And then we can also subtract with lots of arguments. For example, if I have 100, I can subtract 50, later 20, and it has to show me 30. And we can also divide by some numbers. So if I start with 100, I can divide it by 2, later by 5, and by 10, and the output will be 1. So if we say here print me in a new line this operation, and we run the program, and we are a bit patient, the output will be 1 because 100 divided by 2 is 50, divided by 5 it's 10, and 10 divided by 10 is 1. And is this working?
Yeah, so that's the one sort of drawback of using the Clojure replit is when you start using it for the first time, it actually has to re-download Clojure. So the first time you run stuff, it's a little slow. But like Pepe said, the answer is one. And so I'm just going to quickly say something. Like Pepe was saying, all of the time in Clojure, we represent things as these lists of a function and its arguments. And the function is always first. And so this is actually kind of interesting because what we did here is we nested two functions. So we first put division is the first function, and then we put the result of this division expression in as the argument to another function, which is to print. So this idea is really powerful, and we can nest it to get expressions like this. And so something that really confused me when I first learned Clojure is this notation, right? Because if you come from a language like Python, you expect to see something like this. So a way to think about this is that when you have these simple operations and they're done over multiple numbers, you can just pretend that what it means is it means you copy that symbol over between all the arguments. So times 40, 0.1 means 40 times 0.1. And then minus 150/20 means you put the minus in between all of these arguments. And that sort of helps you reason about what the code is doing. But yeah, this is a really cool sort of property that doesn't exist in traditional programming languages, and it all has to do with Clojure's roots as a Lisp, and even deeper, this idea of homoiconicity, which we're going to get to later on throughout in some later videos. So Pepe introduced to us this idea of functions being the first thing in this list, and then we give them a bunch of arguments. So one thing we might want to do is sort of generalize this to conditional statements like if. And technically, I should point out, in this case, if isn't a function. For now, we'll just refer to it as an operator because defining what it is a little bit complicated at this stage, but we can sort of think of it as a function in the sense that it takes in parameters. And so in Clojure, we write if statements like this. Where we take the if operator and we give it three arguments. The first argument is the specific value or condition we want it to evaluate. So in this case, I just told it that the condition is true. And in that case, it's going to do the first thing I told it. Otherwise, it will do the second thing I told it. And so just to quickly map this back to a language like Python, we usually write our if statements in a style like this. But what Clojure does is realize that this else is actually kind of redundant. And we can just sort of represent everything as an if with three arguments. So if you do this sort of transformation, then you get this Clojure form of a conditional statement. So when we run it, it should return the first value because it has a true condition, so it will choose the first value. And again, this might take a little bit of time. Yep. And then just to show you guys that if we turn it to false, it will choose the second value. Right. And so there are other sorts of conditionals, sorry, not conditionals, but control flow operations you can do in Clojure, like do. So I'll let Pepe sort of explain those to you.
Yeah, so sometimes when we have a condition, we want that to do lots of things, but if we write to outputs, Clojure will think that the first thing is the output the program has to do when the value is true, and the second one when the value is false. But if we want the program to do lots of things, we can use do function. So we say to Clojure, if it's true, we want you to print in a new line, for example, it's true, and we also want you to print in the same line 1 + 1. And if it's true, the def function will do both things.
It is complaining because I think it might just be a parentheses issue.
Yeah.
So one thing that like makes this a little easier to read is if we put them on lines like this, we see that we're actually missing the parenthesis for do. So hopefully when we run this again, it will work just like Pepe said. And no, it's complaining again. Let's see. Oh, actually not sure why it's complaining right now. It says the string cannot be cast to Clojure. I think. See if this works. No, it's still complaining. Oh, sorry. Duh.
We have
It's this. So what we did here is we actually enclosed the string in parentheses. And we never want to do, and now we have an unmatched delimiter. So I can add that tent line back in here. Okay, let's just make sure everything is working now. Okay, the do should go there to match this up. And this is one of the things that makes dealing with Clojure and Replit a little bit more difficult, because in a lot of other editors, we color parentheses that match. So it's super easy to see what is related to what. Okay. So hopefully this code will work. Okay, yeah. So Pepe, you can take over sort of explaining.
And so we can use this function to, as I said, do a group of instructions before a condition. And we also have the when function, which is very similar to if, but it has only one instruction before the condition, because when this happens, it's going to, the output will be that, but if that's not happening, you won't have output.
Right, you just do nothing.
Yeah. And I think the output will be nil because in Clojure, I don't know if it's.
I think it would be, like you said, nil. So, and another thing is, because now we don't have to deal with multiple conditions, we assume everything, it's like an implicit do block. So we can just write out a bunch of stuff without having to use do, because now the computer won't get confused if this is for the first condition we should do it, or the second condition that we should do it. And it's also a good thing to point out that when we have a bunch of statements in do, it does all of them, but then it actually returns the last one. So you may have noticed we printed all of this stuff out, but we didn't print the +5, the +5 and 5. And that's because this is what the do actually returns, and it returns it back to the print statement, which then prints it to the screen. So we should get the same output in this case, because it will do the same exact thing, because we only care about this first condition, and that is what we see. So it's write it up here, but if, do, and when are some of the basic brought in, like the basics that we need to do control flow in Clojure. And now it's also important to talk about some more complicated testing conditions we can do. So we can test if two numbers equal each other with the equals function. And again, it's going to take some practice to sort of get used to this, but we don't write 1 double equals 1 like we do in Python. We treat equal as its own function, and we treat the things that we want to pass into it as arguments, and we wrap it all in a list. And just to remind you, the list means evaluate this function on these arguments. So we can test if two numbers equal each other, and then print they're equal or they're not equal. I won't do that because it's not a very interesting example. We can also use and or. So we have these and or functions. So and true will give true, but and any other combination will give false, because and is an operator that only gives true when both of its arguments are true. So this would give false. And then we can also do the same thing with or. We can get or true and false, and it will still give true, because or only cares if one of them is true. But if we give or two false values, then it will also complain. And so we can print all of these out just to ensure they're doing what we expect quickly. And then the use of these conditions is that we can plug them into an if statement, so we can do some more complicated logic. For example, I can take two variables and say if they're equal, print they're equal. Or I can check if three sets of variables using the and condition and see if they're all equal, or something like that. So maybe we'll try that in a second, but first we should just verify that all of this works as intended. And that matches what we predicted. True, false, true, false. Okay, and so while I'm on the topic of variables quickly, maybe Pepe can tell us how we define variables in Clojure.
Yeah, so there's a function which is defined.
Yeah,
I'm writing where I
don't want to do that.
Yeah, define, and we can say, for example, the name of our variable will be x, and then the second argument will be the value of the variable. So we can say that x equals 5, but we can also define variables of text. For example, my name is Pepe. Sorry, when you have text, we have to use these comments. Yeah, so variables can be text or numbers, and they are more interesting to do comparisons and you combining them with the if function, because if we are asking the computer if 1 equals to 1, it seems to be really stupid.
Yeah.
But sometimes we can say, okay, is x equals to 1? If not, you're going to do the separation, for example, x minus 1, and then you're going to check me again if it equals to 1. And that's all of defining variables.
Yeah, so that's exactly like Pepe said. It's the same idea of the first thing we put in the list is this operation or function which we apply to the parameters. And I'll also quickly note in Clojure, it's considered like good practice that if we have a variable with multiple names, we use a dash instead of an underscore. So like an underscore is something you'd use in Python, but in Clojure, if you have a very long variable name, you usually write it like this. And it's not like it's wrong or will throw an error if you don't, but it's just something that is considered sort of good practice. It's part of the style of writing Clojure code. So yeah, now we know how to define variables. So we're going to take a look at another type of data structure called a map. And so if you come from Python, this is usually called a dictionary. And actually it looks a lot like a dictionary. So in Python, we have these dictionaries that look like this. And we have a key assigned to a value, and the colon indicates that they're assigned to one another. Now, in sort of Clojure style, we don't use colons. We just regard every pair of elements as a key value pair. So let's see, I could say plus, and I'll map it to the plus function, and minus, and I'll map it to the minus function. And I will call this the operation map. So let's just quickly go over this. Now, you might wonder a little bit why we can just put the plus there, because if we just put the plus there in normal Python code, that would be an error. Doesn't plus expect arguments? Well, this is again where Clojure is unique. So the plus by itself is just a symbol. It's not going to actually start adding things together unless we put parentheses around it. So this would be wrong. Plus would be trying to evaluate itself, but with no arguments, and would throw an error. Right now, we're not evaluating plus, we're just treating it as some symbol. So we don't really care what it does. we're just using the symbol as a place marker almost. Later on, we can retrieve the symbol and actually call it with arguments, but for now, it's just existing there as a symbol. And this is like one of the most difficult things to get used to coming from Clojure from another language, but we just have to sort of rewire how we think about when symbols are applied and when they're not applied, because there are lots of instances when they're actually not applied. And so what you can do now is we can look up in this hash map or association or dictionary. In Clojure, we call them hash maps though. So we use the get function and we give it the operation map. This is the thing we want it to use to look stuff up from. And now we're going to give it a specific thing to look up. So plus. And so now what we know, right, is that plus is a function. So this bit of code here is just going to get replaced with a plus. So since that's true, we can call it on 1 and 1 and should get 2. And that is what we get. So this is a little bit complicated at first, but we're just using this new type of data structure called a hash map to, which is like a lookup table. And we look up a symbol and then we tell Clojure, now call the function that this symbol represents with these arguments and print the output to the computer. So what is a little annoying is that we have to use the get keyword. So maybe Pepe can tell us a little bit about, not keyword, the get operator. Pepe can tell us a little bit about keywords and how they sort of help us get around this.
Yeah, so keywords, it's we could say when we have a book and it's what helps us when we are working with maps. So for example, if I create here a map, which is going to be with some keywords, A, and it's the keyword for the number 1, B, it's going to be the keyword for number 2, and C is going to be the keyword for number 3. If I say the program that I want the A, print line A, it should show us the number 1.
Oh, yeah, you just want to add one extra set, I think, of parentheses here, because, yeah, so the keyword is sort of, we can treat it as a function that looks itself up in the map. So if we run it again, this should work. But since it's a function, remember, we have to enclose in parentheses. So this should work, though. Did that work?
Yeah, but we have the 2 of this operation.
Oh, I see. Yeah.
Which is showing, yeah. So one thing we have not mentioned yet is that in Clojure, sometimes the outputs are shown all together. As you can see here are 210, sorry. And it's not because we have done an operation that should show us this number, but here between the 14th and 15th line, you can see the 1 plus 1 function, which is 2, and later the 5 plus 5. But it's we have not told Clojure to print this function in order line, so it continues after the 2. And the syntax of the keywords is first 2 dots and later the name of your keyword.
Yeah. So this way, the main thing that keywords do for us is we get to remove the get, and it just looks nicer and it's easier to think about. But really, a keyword is just a function which looks itself up in the map. So we've covered maps. Now I just want to quickly go back to vectors. So remember earlier that we said that vectors look like this. So I'll call this vector words, and I'll just fill it with the text, hello world. So we have this vector here. Now we kind of want to know how we can get different elements from the vector, right? And so we actually use the same get function. So we can say get words, and Clojure is 0 indexed. So that means if we ask for the 0th element, it should give us the first element, hello in this case. And if we ask for the first element, it would give us the second element, or world in this case. So it gives us hello. So we can also create vectors and hash maps, by the way, in a different way. So I can create this other word vector, and I can create it by using the vector function and then giving it hello world. And it will be the same thing as this here. And just for reference, I could have done the same thing with our operation map. I could have said operation map equals hash map, and then I give it plus, and then I just give it the sort of pairs that I wanted it to have. So plus, minus, like that. So this is just a different way of creating these structures. Another sort of important thing when we have these vectors is how we can expand them, add elements to them. So let me just print our word vector again to show that it actually does evaluate hello world. And I accidentally enclosed it in parentheses, which would try to evaluate the vector, which would throw an error. So I had to delete those, obviously, because the vector is not something you can evaluate. It's a piece of data, right? So it prints out hello world. Now we have a function called conj in Clojure as well, which adds an element to the end of a vector. So I could say add 4, maybe add exclamation point, that makes more sense. And this would return a new vector with an exclamation point as the third element. So it's kind of like append in Python. So yeah, these are vectors. And I was talking earlier about how we also have lists in Clojure. So vectors are the closest thing to sort of arrays in other languages. And we're going to get more into this later on. But in vectors, you can sort of look values up anywhere in the vector much more efficiently than you can do in lists, because lists are meant to be accessed in a very sequential order. So you're supposed to access them, the first element, then the second element, then the third element, in that fashion. And actually, there's a sense in which all of the code we're writing here is in a list, because we're enclosing everything in parentheses. But we're going to get more into that later as well. For now, I'll let Pepe show you how you actually define a list of data and what functions you can use with that, as opposed to vectors.
Yeah, as we have said, in vectors we don't use parentheses. What have I done here?
I think you just have to go. Yeah, that's just good.
So if we want to create a list, we are going to use parentheses again, such as where function, and we can create, for example, right now I'm creating a list of numbers, such as the example in the book, and we can use the function, for example, end function, and later we will give this a list. A number is not a function. What's happening here? So we give a list 1, 2, 3, 1, 2, 4, 5, and I want the second element, for example, of my list. So if I say the program print in a new line.
And I'll just quickly add one thing, is that you may be wondering, why is this going to work, right? And it even says here, a number is not a function, because we told you that functions always go as the first element in a list. So what we have to do to make this work is put a little, Pepe just added it, a little quotation in front of this. And what this tells the computer is, you don't actually want to evaluate this. So usually what it would do when it receives a list is it would evaluate the first element, the operation or the function, on all the other elements. But we're telling it, in this case, we don't want you to do that. We just want you to leave the whole thing alone and not evaluate it at all. So we just want it to remain in this form. Of course, we could also do the same thing for something like the functions above, +1, 1. And this would just remain +1, 1. But in those cases, we actually want the plus to do its operation. And this is a really confusing idea, but it underpins one of the coolest things about Clojure, which is macros. And again, something we're going to get into later. I feel like I keep pushing a bunch of the cool stuff of Clojure to future videos, but that's because we really need to get these basics down first. But yeah, so this just tells Clojure, do not evaluate this. And so Pepe, you can run it. And like he said, it will return the first element of that. And of course, first means second, so it will return 2. And so, like I said earlier, this is technically not as efficient as looking up elements in a vector, because vectors are meant to be accessed in a nonlinear way, whereas lists are not. So this is not technically as efficient, but that's not really something we're going to worry very much about now. So I think we're going to just wrap up with a few more important vector list functions. So the first of these is first. It takes a vector and returns the first element of the vector. And then we also have rest, which is the opposite of that, but it returns everything but the first element of the vector. So these will print 1 and 2, 3, 4 respectively. And you may be wondering why something like this would be useful, but when we start doing some problems, we will see that these are actually quite useful. Okay, so you can see it returns 1 and 2, 3, 4. And actually, you'll see that this vector now becomes a list, which is one of another confusing thing about Clojure when you're starting as a beginner. And I know it confused me for a while. So we're not actually going to go into this now, but just keep that in the back of your head, sort of. So we also have functions take. And this lets us, I think I put the arguments in the wrong order. It lets us take a certain amount from the beginning of the list. So we can take the first 3 elements of the list. And this is going to give us 1, 2, 3. So we get 1, 2, 3. And then we can also do drop, which will drop the last 3 elements from the list and just give us 1. Or sorry, drop the three elements from the beginning of the list, not the end of the list. I misspoke. But yeah, these are a lot of the core things that make up Clojure. And so there are a lot more cool things that we're going to get to in future videos, but this is the sort of basics you have to master before we can start getting over to that stuff. And so it's really just re-teaching yourself how to look at and read code in this way, where we define everything in terms of parentheses and we define everything in terms of functions applied on arguments. So yeah, it's going to take a little bit of work and practice. It definitely took me a long time before I felt comfortable with Clojure, but what you get in return for this effort is a really expressive functional programming language. And we'll touch more on how Clojure enables you to use functional programming techniques in our next video, actually. But you can see here, even if you've noticed sort of the Python code that I was sometimes writing, the Clojure code is much more concise and it sort of packs much more of a punch, and it lets us do really complex things in a very small amount of code because of the operations the code provides us with. So this is the end of our first video. I'm not sure if Pepe, you have any other closing remarks you'd like to offer too, as someone who's starting pretty recently with Clojure, how you think about it.
I think when you are starting with a new program, you have to be a bit patient, be really careful first times you're writing code, you're typing code with the syntax, because if you have programmed before on Python or C++, when a few things change, you have to change your mind on the way you are writing code, and nothing more. If you know someone who is interested in computer science and programming, let them know that we are creating this hackathon for the last week of September, I think.
Yeah, last week.
And so if you know someone who can be interested, send them the form and because we need more people in
Yeah.
our contest. So
And
thank you very much,
yeah,
guys.
we really urge you to try out Clojure. Like, it may seem a little intimidating, but I can honestly say that Clojure is the language that has changed my attitude to programming the most, sort of when I started learning it in the beginning of high school. And it's just a really rewarding language to learn. So I really recommend you dive into Clojure and make sure to check out our website. And if you haven't already, register for the SLN conference, and we'll leave the links to all of that in the video description. And I've been mentioning we're going to be making more videos. So we're going to be releasing a video every week until the conference, so throughout the summer. And that will allow you to get a lot of the basics of Clojure and even a little bit beyond the basics. So make sure to keep checking back regularly. But until then, we'll see you next time. Bye, guys.
Yeah, and if you have any doubts, you can write us to our emails.
Yeah.
Mine is papa islanconf.com. We can put them in the description, or hello islanconf.com.
Yep. Okay. Bye, guys.
Bye.
Okay. I thought that went pretty well, actually. Did you think that was good also?
Yeah.